All right, so a binomial probability distribution is really just being able to show all of the possible outcomes, and then the histogram will allow us to visually see what's happening. So 65% of households donate to at least one charity. You asked 5 randomly chosen households. So we're going to need to do all of the outcomes possible here from 0 to 5, because we could have 0 of those 5 say they donated to a charity all the way up to 5 out of 5. So we'll start with 5C0 all the way down to 5C5. And then for 5C0, that would say the 65% chance that they have raised to the 0 power, and then the chance that they have not is 35%, and all 5 of them would fall into that category. So then you're going to keep this pattern going. So this would be 1 and then 4. 2 and 3. This one would be 3 and 2. And then 5 and 0. So we're going to type all of those into the calculator, and when you do that, you end up with these numbers right here. So in this chart, X stands for the number of people that would have said yes, or the number of households that would have donated, and then the probability of that happening. So for the histogram, we've got our x-axis, and because it's a histogram with the bar graphs, I'm going to put the markings here kind of in the middle, since we'll go up from there. And then in terms of the y-axis, which is the probability of x, the highest we have to go up to is 0.33, so we could jump by 2 markings here and do 0.1, 0.2, 0.3, and 0.4. So then for 0, it's 0.005, which is less than 1%, so it's going to be a teeny tiny little bar right there. 1 is going to be just under 5%, which would be right there. 2 is going to be a little bit under 20%. I went a little bit too far there. Somewhere about right there. 33% is going to be up here. 31% will be just below that. And then 11.6% will be just above 10%. And to check these, you could add up all these numbers together. They should be very, very close to 1 depending on the rounding, and the reason they come out to be 1 is because we've taken care of all of the possible outcomes that could happen. So then for these last 2 parts, we're really just using the numbers that we've already come up with and figuring out what to do with them. So letter B is saying, what is the probability that at least 1 household will have donated? Well, we want to do 1 minus the probability that none of them have donated, or 0 of them, which is the only outcome we don't want. So that would be 1 minus 0.0053, which is 0.9947. And then for letter C, you have a couple options here. So no more than 3 households. You could do the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. You could also do 1 minus the outcomes you don't want, which would be the probability of 4 or the probability of 5. Either way, you get an answer around 0.5716. And again, that would come from just adding up these numbers right here, or taking those 2 numbers and subtracting them from 1.